Intermediate Algebra for Statistics, Solving Linear Inequalities in One Variable, Part 2, Lesson Objectives, Graph Inequalities, Solve Linear Inequalities. Recall inequality symbols. For many students, it's very easy to get confused with greater than symbols and less than symbols. So when I first learned inequalities, Pac-Man was very popular. Here we have two inequality statements. One of them's true, one of them's false. So if we can remember that the Pac-Man will always eat the largest number, this will help us remember which way is correct. So here's the first one. The Pac-Man is eating the 7. And for the bottom one, the Pac-Man is eating the 5. Since 7 is larger than 5, this one is the true statement, this one is the false statement, because the Pac-Man will always eat the biggest number. So this one is false, this one is true. Solving a linear inequality. Number 1, simplify the algebraic expression on each side. Number 2, use the addition property of inequality to collect all the variable terms on one side and all the constants on the other side. Number 3, use the multiplication property of inequality to isolate the variable and solve. Remember to change the sign of the inequality when multiplying or dividing by a negative number. Number 4, express the solution set in a set builder or interval notation and graph the solution set on a number line. So here's the relationship between an inequality and an equation. An equation always has an equal sign, and in this case this equation solves to x equals 3, and this is the graph. Out of all the numbers on the number line, there is only one number, 3, that will make this a true statement. For the inequality, it turns out in this case x is less than or equal to 3, and we have an infinite number of points here that will make this statement true. So all numbers that are less than or equal to 3 will make this a true statement. Solution, solution set, and solve. Definition. We say that a number is a solution of an inequality in one variable if the number satisfies the inequality. The solution set of an inequality is a set of all solutions of that inequality. We solve an inequality by finding its solution set. Just like in the previous slide, the solution set was all numbers less than or equal to 3. There was an infinite number of solutions for that solution set. For the equation, we only had one number, x equals 3. Math manners. For single inequalities, always have the variable on the left side of the inequality. So here we have the Pac-Man is eating the x, 3 is less than x. But if we use good math manners, we should write it as x is greater than 3. These two statements are equivalent. If we use good math manners, this is the way we should write it. Let's do an example. Example 2. Solve and graph the solution set for the inequality negative 2x is greater than 10. To get the x by itself, we need to get rid of the negative 2. Since it's multiplying the x, we do the opposite and divide by negative 2. And if we divide by negative 2, we have to remember to flip the inequality sign. So we have x is less than negative 5. So to graph it, we go to negative 5. We put an open circle because this does not have an equal to, and we want all numbers less than negative 5, or to the left of negative 5. In interval notation, it would be parenthesis negative infinity, comma, negative 5, close parenthesis. Example 3. Solve 2x minus 3 is less than 7. Describe the solution set as an inequality, an interval notation, and in a graph. Solution. So we need to get rid of the 3 and the 2. We get rid of the 3 first because we're following the order of operations in reverse. So we're going to get rid of addition and subtraction first. So we add 3 to both sides, and we're left with 2x is less than 10. To get rid of the 2, we divide both sides by 2, and we're left with x is less than 5. So that's the inequality. The solution set is a set of all numbers that are less than 5, which we can write in interval notation as parenthesis negative infinity, comma, positive 5. This is the graph, and again, because 5 is not in the solution set, we have an open circle here at 5. Example 4. Solve the inequality 3x is less than 9x plus 4 and sketch the solution set. So we have 3x is less than 9x plus 4, and because we want the inequality to be on the left hand side, I'm going to subtract 9x to both sides. We want all the x's on the left hand side. This becomes negative 6x. Bring down my inequality symbol, and we have 4. Now to get rid of the negative 6, I had to divide, and we're left with x. Because I'm dividing by a negative number, I have to flip the sign. Positive divided by negative is a negative, and 4 over 6 reduces to 2/3. So the inequality is x is greater than negative 2/3. The solution set is all numbers greater than negative 2/3. And we can write this in interval notation as parenthesis negative 2/3, comma, infinity, parenthesis. The graph would look like this. I would put negative 2/3 in the middle. We would want an open circle here because this is a greater than, not a greater than or equal to. And we want all numbers to the right, all numbers larger than. So any number to the right of negative 2/3 is a solution. Example 5. Solve 2x minus 5 is greater than 6x plus 3. Describe the solution set as an inequality in interval notation and in a graph. Solution. Our first step is to subtract 6x to both sides of the inequality. This gives us negative 4x minus 5 is greater than 3. Add 5 to both sides, and we're left with negative 4x is greater than 8. Divide by negative 4, and don't forget to flip the sign because we're dividing by a negative number, and we're left with x is less than negative 2. So the solution set is all numbers less than negative 2, and interval notation that would be parenthesis negative infinity, comma, negative 2, parenthesis. Here's our graph. We want all numbers less than negative 2. We can use the graphing calculator to verify our result. We go to the y equals. We put in 2x minus 5 for y1, 6x plus 3 in y2. Using our table feature, which is second graph, we can see when x is negative 2, y1 and y2 are the same value, negative 9. And when x is less than negative 2, smaller than 2, we have y1 being larger than y2. If x is greater than negative 2, we have y2 being larger than y1. But for this problem, we want to know what values of x is 2x minus 5 greater than 6x plus 3. And the answer to that is numbers less than negative 2. Example 6. Solve 3 times the quantity x minus 2 is less than 5x minus 3. Describe the solution set as an inequality, in interval notation, and in a graph. Solution. Our first step is to distribute the 3. So we have 3 times x minus 3 times 2. That gives us 3x minus 6 is less than 5x minus 3. Our next step is to subtract 5x to both sides. We're left with negative 2x minus 6 is less than negative 3. Add 6 to both sides. We have negative 2x is less than 3. Divide by negative 2. We have to flip the inequality sign because we're dividing by a negative number. And we have x is greater than negative 3 over 2. In interval notation, we have parentheses negative 3 over 2, comma, infinity, parentheses. This is the graph. All numbers greater than -3/2. Again, we can verify this by using the graphing calculator. We type in the left-hand side of the inequality in y1. We type in the right-hand side of the inequality in y2. Using our table feature, we can see at a -1.5 the values are the same, and if we look at x's that are larger than 1.5, we have y1 being smaller than y2. So we have verified this by using a graphing calculator. Thanks for watching.